Myself Vaibhav Khan Singh, and today we'll be having a discussion on Banker's algorithm. Banker's algorithm, which is an approach for deadlock avoidance where multiple instances of resource types they are there. In our previous discussion on deadlock, we were able to cover what deadlock is, what the system model is for the resource allocation, and the necessary conditions for deadlock, that is mutual exclusion, hold and wait, no preemption, circular wait, resource allocation graph algorithm, methods to handle deadlock, deadlock prevention. Deadlock avoidance, we had a brief overview and we were able to cover resource allocation graph algorithm where the utilization it goes if you are having a single instance of resource type. For multiple instances of resource type, we will be making a utilization of Banker's algorithm. Banker's algorithm is called Banker's algorithm because if you see the policy that which is adopted in this algorithm, you will see an analogy with what it happens in the banks while the distribution of cash it happens, how the bankers they are making a distribution of cash to the customers that which are coming at their place at a particular point of time. How the distribution it goes, you will see analogy with that. So that's why this algorithm it is also called Banker's algorithm. And there will be a few terms which will be utilized when we will be making inroads on Banker's algorithm. The term that which will be utilized or is utilized by the operating system to make an assessment whether the system is in a safe state or not. It is called safe sequence, and safe sequence it specifies the order of the processes in which the operating system it offers resources to its maximum potential, and still deadlock is something that which is avoided. We'll be having a better picturization of that in a short while. Beside that, now if a safe sequence is there, the operating system it says that the system state is a safe state. So operating system it says a resource allocation state will be there, and operating system will say that this resource allocation state is safe in case the operating system by means of a mechanism it is able to derive a safe sequence. So safe sequence is something that which is very important. We'll be trying to find out whether a safe sequence it is there or not in Banker's algorithm. If a safe sequence is there, then we will say okay, the system is in safe state. Then there will be some data structures which will be utilized for making this assessment whether the resource allocation state is safe state or not. So the data structures will be max, which will be an n cross m matrix, and where n it is the total number of processes, m it is the total number of resource types. Allocation, again it is a matrix the size of which is n cross m. N it specifies the total number of processes, m it specifies the total number of resource types. There is another matrix that is need. Again the size it is n cross m. N it is the total number of processes, m it is the total number of resource types. A vector available the size of which will be m, which is the total number of resource types. Now coming up, what these data structures, the information they are carrying, max, it carries the maximum resource requirement of a process. Allocation, it specifies what the allocation to the process is when you are making an assessment. At that point of time, what the resource allocation is to a particular process, allocation will tell you that. Need will actually tell us the amount, what the extra requirement of resources is. Max is there, which specify what the maximum requirement will be. Allocation will tell us what is allocated. So max minus allocation will tell us the need value. Beside that, we are having available, and available will speak of what the availability of resources are. If suppose a resource type A is, and in the system the number of instances of resource type A is 10, then at the time of assessment it may happen that the availability it is 4, because out of 10, 6 they are allocated to some of the processes which are there in the scene, and 4 is something that which is available still for allocation. So need is there where some processes may be having a requirement for that resource, and available is something which will make the operating system to say, okay, you are demanding for 2, I am having 4, so I can give you 2. So available is a vector which will help the operating system to check what the availability of a resource type when the assessment it goes, it is actually there. Then deadlock avoidance, already we had a discussion that additional information is something that which you are supposed to pass, and the process it is passing to the operating system, and operating system it is making a utilization of the additional information, and on the basis of additional information it is actually assessing that whether a request for a set of resources by a process it must be granted, or the process is to be asked to wait. So we'll be making a discussion on an algorithm that is called safety algorithm. This safety algorithm, it comprises of 4 steps, and in these 4 steps the idea it would be to generate safe sequence. And if after this algorithm it is over, if the operating system it is able to generate a safe sequence, then we can say that the current allocation state is a safe state. So there is a vector work, there is a vector finish, the size of work is m, the size of finish is n. Work it is initialized to what is there in available, finish is initialized to false. All the elements of finish they are initialized to value false. Then in second step we are trying to find out an I such that there are 2 things we are checking. If both these 2 things they are true, then we'll be going to step number 3. Otherwise we'll be going to step number 4. If both these conditions they are true, then work will be updated by this value, that is work will be equal to work plus allocation of I, and finish of I will be set to a value true. So if you see in the first step, we are initializing the value of work to available, finish the size of which is n, every value of n is initialized to a value false. In the second step, we are trying to find out an I such that both finish of I is equal to false is true, as well as need of I less than equal to work is also true. If both these two things they are true, we'll be moving on to the third step, where work will be updated with work plus allocation of I, and finish of I will be assigned a value true, and then we will be moving on to step number 2. If these two things, that is finish of I is equal to false and need of I less than equal to work, if these two things we are not able to find out an I where these two are true, then in that case we are going to step number 4, where in step number 4 we are checking whether all values of finish of I are true. For all values of I, you are checking all the elements that are there in finish, you are checking whether all the values they are true or not. If any value it is false, then we say that the system it is in unsafe state. If all the values are true, then we say that the system is in a safe state. Now to have a better picture of how the algorithm it operates, consider a system which comprises of 5 processes, P0, P1, P2, P3, P4, and 3 resource types are there, A, B and C. The total number of resource type of A is 10. The maximum amount of A that which is available in the system of resource type A is 10. Likewise, the maximum amount of resources that are available, the number of instances of resource type B available in the system is 5, and likewise the number of instances of resource type C available is 7. Now coming back, I gave you a brief note on max, allocation and need, and also available I gave you a brief note. Now I gave you the picturization that it is a matrix, so you can see matrix it is there, and P0, P1, P2, P3, P4, these are specifying the processes A, B, C, resource type. So n, the value of n will be 5 and the value of m will be 3, and this value 7, what this value 7 it actually specify is a process P0 is there and a resource type A is there. 7 is the maximum requirement that which the process P0 is having of resource type A. Likewise, what 5 it is specifying? 5 it is specifying the maximum resource requirement of P0 of the maximum instances of resource type B. that which is required by P0 during its lifetime. Likewise, 3, it is specifying the maximum instances of resource type C required by P0. So this vector 7, 5, 3 is actually specifying the maximum resource requirement of P0. Likewise, if I make a consideration of P2, then 9 is the maximum resource requirement of resource type A by P2. This is the maximum instances, like 0, it is the maximum number of the maximum instances of resource type B required by P2. So this vector, it specifies 9, 0, 2. This specifies the maximum resource requirement of P2. Now coming to allocation. Allocation, if I go to any cell like this value, 3 value, it is specifying the maximum, 3 value, it specifies the allocation that is made of resource type A. So 3 instances of resource type A is allocated to process P2. Now make a consideration of this one. This one, it specifies the number of instances of resource type B allocated to P2. And if I make a consideration of this 2, 1, 1, this 2, 1, 1, it specifies, this is basically a vector, and this vector, it specifies the resource allocation that is made for process P3. 2 instances of A made for P3, 1 instance of B made for P3, 1 instance of C allocated to P3. So this is what the allocation is for P3. Then need. I already told you, max of Ij minus allocation of Ij will give you need of Ij. In other words, this is first row, first column. This is first row, first column. Max of first row, first column minus allocation of first row, first column will give you need of first row, first column. Or to be more general, max of Ij minus allocation of Ij will give you need of Ij. You can check any value. Now checking this value. This is row number 4. Row number 4, column number 2. So row number 4, column number 2, max row number 4, column number 2. The value it is 2. And allocation row number 4, column number 2. The value is 1. So 2 minus 1 is giving you a value 1. So likewise, I am able to generate this need matrix. Max of Ij minus allocation of Ij will give my, so this vector, it specifies what the extra, what more requirement of the process is. Some allocation it is already made, maximum requirement is there, some allocation is made, what is more required by the process to complete its task. Need is going to specify us that value. Now coming to the starting point where I specified you that the number of the number of instances of resource type A available is 10. in the system. In the system we are having the number of instances of A 10, the number of instances of B 5, and the number of instances of C 7. So some allocation is already made. So if you see what allocation it is made of resource type A, we will be adding this value. 2 plus 3 plus 2 will give us 7. 3 plus 2 and this will give us 7. And we are having 10. So 10 minus 7 will give us 3. Likewise, the instances of B available 5. What is allocated? 2. 1 plus 1, 2. So 5 minus 2 will give us 3. So what is available? The number of instances of B available 3. The number of instances of A available, this value it is coming up 10 minus 7. 5 minus 2. Likewise, 2 plus 1 plus 2, 5, and 7 are there. So 7 minus 5 will give us 2. So this is the starting point, and now we'll be coming on to the algorithm. So I made this table to explore as to how the algorithm it is going to. I made this table to actually give you an idea as to how the algorithm will operate and how we'll be able to generate a safe sequence. So the table, it comprises of 4 columns are there. The column heading, process found, current available, safe string, and mark. So if you see the algorithm, we already went over the algorithm. Algorithm, in the second step, it searches for a value of I such that there were 2 things which are supposed to be true. The first thing was finish of I, it must be equal to false, and if you see in step number 1, we made an initialization of finish of I to false. So that is something which you will find out with every value of I. Beside that, there was one more thing that which you were checking, and you were checking that need of I should be less than or equal to work, and work it is initialized to available. So in this, the column headings, if you see, process found is there, where we are supposed to find a process such that those two things they are true. So if the process where those 2 things they are true, will be specifying the name of the process over here. Then in step number 3, if those 2 things were true, then in that case we were making an updation in the value of work. And what the updation was, work it was equal to work plus allocation of I. So this will specify the value of work, the first part, and this will specify allocation of I, and this will be the modified value of work. After every iteration, 2 updations will take place, and the second updation was we were setting finish of I, the ith element of the vector finish, it was assigned a value true. So here in this table, this column marked is actually specifying the setting of the value to true. mark of P1 is actually specifying that we set the value of the ith element to true. And then the idea is to generate safe sequence, which will be an order in which we are making resource allocation. So safe string or safe sequence is what we are trying to make a generation of. So there is a column that is meant for that also. Now coming back to what the state is, resource allocation state is, and on that applying the algorithm. So we'll be starting with work will be there, and work is initialized to 3, 3, 2. 3, 3, 2. Further updation we'll see over here, and we are having finish and finish all the values they are initialized to false. 5 processes are there and all initialized to false. Step number 1 this happens, and then going to step number 2, where we'll be checking. So finish of I, every value of I if you see false, so you can go with any value of I. But the second point, that is need of I is less than equal to work, is something that which we are supposed to make a checking of. So if you are starting from here, then make a comparison. The need of the number of instances. Now P0 is the process, the number of instances that it require of instance, the number of instances of resource type A required by P0 is 7 and available is 3. So this is something which is, it could not be granted. You are having 3 and you are asking for 7. So it could not go. So this is something you cannot make a selection of P0. Now check for P1. The value that which is required is 1. The value that is available is 3. So okay. Here for A, okay. Now you will be checking for B. This value is 2 and this value is 3, okay. 3 is more than 2. So okay. Now check for C, the value is 2 and the value is 2. So 2, it is equal to 2. So we can actually make a selection of process P1. So we are able to find out a process, the name of which is P1, where both those conditions, that is finish of I is equal to false and need of I is